YouTube right now.
Okay.
And I'm going to start the webinar.
Okay. Hello, everybody. All right, working out a couple of technical issues today, but we got it working. Hello, everybody. Welcome to our faculty Q&A for May 2021. I can see that people are coming in here on Zoom. We always welcome you guys who are part of our academy, members in our academy. We're so grateful to have you here. And everybody else. Today, we're just live streaming on YouTube.
A little bit of echo.
Oh, echo? Well, I don't hear it on my end, and I don't know what to do about it at the moment. Is it bad, Jamie? Is the echo bad, or is it?
It's long delay style.
Really? I have no idea why. Back in. Hopefully that maybe made a difference. So anyway, we're live streaming on YouTube and here live with you guys on Zoom today. And this is our faculty Q&A. We have Jamie and William Brown, myself. Did you guys say Inez? We're not sure if she's coming. Is that right?
Yeah, I don't think she's going to make it this time around.
Right.
She was just traveling back down to Mexico, so
okay.
she might actually be in transit.
Okay. And ironically, I'm just downstairs from Adam Apollo in his house, and he would be here today, except for he has some very important meetings for his venture that he's working on for Core Network that had to get scheduled today. So he's just upstairs, but he's he's beaming in with his intention as it is, and says hello to everybody. It's been really great to get some time to spend here in Boulder, Colorado, which is where I am with Adam, and I'm going to be here a few more days. And I'm on a journey myself, traveling across the country and kind of in the exploration of what's next in the world. And it's such a dynamic time. It's very changeable. So it's exciting, and I'm having a great time with that. How about you, William? How are you doing? Why don't you give a little hello and say what's happening in your world?
Yeah, doing great. Definitely I echo your statement that it's an interesting time, but yeah, things are going really well with research and all of our experiments with the resonance-based technology here, the art crystal technology. That's all moving along very well. So that's been great. I actually just had an article posted to the Resonance Science Foundation. And it's just something that has been on my mind a lot because it's just such an interesting study that has lended a lot of support to our work with holofractogramic physics, even a lot of corollary findings that we presented in our paper, The Unified Space Memory Network and Unified Physics in the Entanglement Nexus of Awareness. It's this really interesting study where, I'm sure we've all seen those images comparing an actual microscopic slide image of the brain at the neuronal level with the cosmic web that is supergalactic clusters, and they look amazingly similar. And it's just a side-by-side picture, and so there's kind of some skepticism among more technical type folks, scientists, that, well, it's just the brain trying to put pattern where there is none, so sure, the cytoarchitecture of our brain does look a lot like the cosmic web in this particular image comparison, but these are separated by like 27 orders of magnitude, and one's made of galaxies and stars and black holes, and the other one's organic molecules. So the similarities are, it's just an interesting kind of quirk. But actually, these two researchers, an astrophysicist and a neurobiologist, did a quantitative objective comparison between the two. So using a mathematical analysis, and they found that they actually are, mathematically speaking, structurally similar. So it's not some subjective phantasm. The cosmic web really does have the same structural organization as our brain. And that immediately is kind of interesting, kind of suggestive, because okay, the universe at the largest scale has the same organization and structure as our brain. And if you go into some of their analysis, they show that if you consider galaxies about the size of the Milky Way and above, there's roughly the same number of galaxies in the observable universe as there are neurons in the brain. That they then go on to show the amount of information processing occurring. So, this is like an analysis of the complexity of, like, let's say, the cosmic web. And looking at several parameters of interaction of magnetism, plasma dynamics, gravitational acceleration, these kind of things. They actually calculate an estimate for the amount of bits being processed in the cosmic web. And it's about 10 to the 16 bits, which happens to be the same estimate for the amount of information being processed by the human brain. And so actually it leads them to state, in no uncertain terms, this is a direct quote from them: your life's memories could in principle be stored in the universe's structure.
Wow, really?
Yeah, and that's pretty much like one of our main points in the unified space memory network.
Absolutely.
Yeah. So, I think though that those estimates on the amount of information processed, are extremely low, 10 to the 16 bits. Because I don't think they're actually, in terms of the brain and the cosmic web, considering all the different kind of interactions that are processing and storing information. So, I think that's a low value. But in any case, I think if you were to factor it all in, it'd still be the same, but just a much higher capacity for information processing.
So if there was a Planck scale consciousness being, or a unit of consciousness at the Planck scale inside of our brains, they would think that they were in a universe right now. Like our brain is an entire universe to some being or consciousness at that scale.
I mean, that's what it looks like. It's it's kind of difficult for me to even conceptualize it that way, but I mean, it's almost like we are in a brain the same way that a Planck scale being entity would be inside our brain. Wondering.
That's good. I'm glad I made it difficult for you to think of something. It's hard to do with William Brown, you guys.
But that's one of the missing pieces, though, is that we're only just now like being able to kind of probe the structure of the Planck scale. But I'm certain that as that capability comes online and we're able to actually probe and map the structure of space-time at the Planck scale, we'll see that it is that same holofractal reiteration of organization. So it'll have the same pattern, the same organizational structure as our brain, as the cosmic web, and it's like this same pattern repeating at scale intervals, and then probably so the same kind of neuronal network of space-time structure at the Planck scale, and then probably our universe as part of a multiverse. The multiverse is probably in this neuronal type architecture as well. So it's great. It's brains all the way.
Yeah.
A great mind, you know.
One great mind, one brain, one system.
Uh-huh. Uh-huh.
I mean, when you have a holofractal model, that's what it's really founded upon, as the understanding. And so to be seeing it actually being correlated at this scale, not as a, wow, that's an interesting random relationship, but actually direct correlations that are very accurate in some ways. And yeah, to extend that down into the Planck scale, it logically would be suggested that it would end up that way, and it would be very interesting to see. When I have seen some, the 3D imaging modeling of the activity of the quantum vacuum fluctuations, that I would say, if they were to be mapped more in their, maybe the vectors and the connections between all those, fluid, it's a very fluid motion. It seems to be that it would correlate quite well.
Yeah, John Archibald Wheeler, one of the first physicists to really do a quantum treatment of space-time, that's how he described it, was a multiply connected, ever-changing space-time geometry, that when you model that, it actually does look very neuronal, with, long extensions. In this case, they're actual quantum wormholes connecting nodes. So it actually does look very neuronal, recapitulating the same pattern that you see in the brain and in the cosmic web structure.
I feel like we historically have tried to put brackets around our conception, kind of like this image where it's like, okay, the universe is kind of as big as it gets, and there's the observable universe that we can't see past, right? It's this horizon that seems like it's continuously getting bigger and bigger and inflating. There's questions as to whether or not that inflation is real or just perceived. But if the pattern holds true, then it goes past the other side of that, which is the Planck, right? Where we're like, we can't really see past the Planck that much, but Nassim has been calculating, and Olivier and yourself, about the sub-Planck being super duper ridiculously small, and that the Planck is actually halfway between the sub-Planck and the universe, which is a like crazy concept right there. You're like, okay, now I'm thinking way smaller than the smallest I was already trying to think before. And the same thing should happen the other way, where the universe could be like a Planck or a proton in this in something else that's like so much bigger than the universe that we are like super far off, and that the universe is actually tiny, and we just haven't figured that out yet. It seems like that's where that's going, right? Where it does go infinitely smaller and infinitely bigger, and you can throw out the word infinity, but to actually try to conceive of how big that is like, you can't do it. That's the whole nature of infinity. Nope, it's bigger than you thought. No, it's infinitely bigger than you just thought again and again. Right. So if that's true, then we're just kind of, like I like to say, like we're perceiving the universe through a cocktail straw with our eyes, right? You can just see this tiny little pinhole, and then we're moving it around a lot over a long period of time and adding up all the information we got from that little pinhole and being like, oh, I think I see what's going on here. And then we go, oh, whoops, it's actually way more complicated than we thought. That's the history of science in a nutshell. So it's exciting because it's not going to stop. We're not going to be like, oh, we figured it out, we're done.
Yeah.
It's just going to go, so everybody have fun is what I'm saying. Enjoy the ride while it lasts.
Absolutely. Got to do that. Well, I just wanted to round out that idea that you're bringing to us, William, with referring back to the Unified Space Memory Network paper. And for those who are here on Zoom or listening on YouTube, who are not familiar with the research papers that Nassim and William and others have written over the past many years, actually. All those papers are available to read at resonancescience.org. And in the Unified Space Memory Network paper, From Cosmogenesis to Consciousness, it's really presenting a model of the multiply connected, unified network of information flow, that from which then the attributes of what we call consciousness arise. And when we think about if that's actually the case, which there's a lot of, I find it to be quite a sensible understanding, and a theory to really at least found a premise for the arising of consciousness, and then the relationship of our biological systems as part of a continuum of the manifestation of energy, matter, and information, and in greater complexity, what we call intelligence and consciousness. It would make sense that that one unified system would function and look the same at all scales. And so you see that neuronal network pattern in the universe, in the brain, at in the mycelial networks of what's in the ground. All of it is not surprisingly looking very similar when the system is actually one system doing the same thing at all scales. So just wanted to bring it back around to that insight from the paper as a foundation for even considering why that would be the case. So yeah, great. Thank you, William. Jamie, you had any other updates in your world that you want to share?
Well, I could talk about the Resonance Science Foundation updates. There's an exciting new course that just launched from Alan Green. It's in the pre-registration mode in the sense that Alan is still working on the content. Basically, Alan Green is a Resonance Science Foundation faculty member who's worked for 17 years straight, basically daily, all day, decoding crazy amounts of information that's embedded in the works of Shakespeare, which is actually probably written by a group of people, he is determined now. It's not just one ghostwriter. William Shakespeare never sent a letter to anyone in the history of his life that we know of. So there's a lot of anomalies there. And then when Alan digs into it, it turns out he's encoding geometries and relationships of the Great Pyramid of Giza in great detail. And it connects to Leonardo da Vinci's work and all this stuff. And his new course just went up in the Resonance Academy. You can go to the courses tab of resonancescience.org. And he's going to do it in the form of a chessboard with 64 squares, as you know. And each time you complete a module or a section of this, you move your knight on what's called a knight's tour until you complete every square of the chess with never repeating a square. There's a pattern you can do with a knight in that weird position it does in chess. And he's doing an hour video for each square. So this course is 64 hours of video.
Oh my God.
And he placed the pricing at the pyramid sonnet of Shakespeare's sonnets that represents the middle of the sonnets, sonnet 153. So it's going to be highly encoded, highly interesting. That course is coming. I think he's going to start the videos in the summer. So it's in the spring pre-registration, but I'm working with Alan and I've been seeing some of the material that's coming in this course, and it's so epic. Alan is just such a brilliant guy to be deciphering this stuff, and he presents it with such clarity and humor all the time. He's got that dry British humor that I love. So I'm excited about the Resonance Academy because we have a whole slate of courses that are going to be coming and rolling out. And that reminds me, William, I put you on the spot every week. How's Big Questions 2 coming? Or is that what it's called?
Yeah, big questions too. Yeah. The living universe.
Oh, nice.
Yeah. It's coming along. I still have a goal for a launch date of 2 months out.
Oh, wow, cool.
Yeah.
It's still the
So
same 2 months.
still the same 2 months. So it's just this
It's like
last
the universe expansion. The horizon keeps receding as you work on it.
this last month just went by in like a flash. It was amazing, and there was just some actually really important things to come through that I think make the timing just perfect. Because it's kind of like the universe sees that this is coming together, and it's like you're going to need this piece. You're going to need this piece, and it's like you kind of have to give it a little bit of time for those things to make it into your sphere. So but it's coming together, and I'm really excited about it because it's kind of the necessary, I guess you just could say follow up, but the necessary next step to complete the discourse that started in Big Questions 1, because we started off with what is space, what is time, so fundamental, most basic level. I kind of built up from there, and it was just getting into some of the biology, the aspects of information processing in biology and consciousness. And so it's going to pick up from there and kind of complete the picture of, okay, the big picture of where we're at, and start looking at where we're going. And so I think that's some of the most interesting parts of the big picture of the big questions, is because that's one of the biggest questions of where are we going. And I think there's a lot of insight we can glean from an analysis that's presented of the past to the present in terms of the evolution of the universe, and what mechanisms and dynamics were underlying this kind of self-organizational emergence of greater and greater levels of coherence and synergistic organization. So if that trend continues, what does that mean? And actually, it gives me a lot of excitement about the future, and where we could be going if we follow that historical trend of going to greater levels of coherent ordering and synergistic organization.
Mm-hmm. That's exciting. Wow. Gosh, I hope this 2 months is happens within this year.
Yeah. Well, I want to get it done. So it's an imperative.
I'm sure you will, and it's going to be obviously very compelling and mind blowing, no doubt.
Yeah,
you bring these ideas together. So, wow, some amazing.
It's
stuff.
actually it's an encouraging, exciting time to be alive. And despite the challenges that we've been facing recently, if you look at the big arc, if you can pull out far enough from history and look at quality of life and all the advancements, it's like things are actually better now than they've ever been in most ways, not in all ways, but in most ways, life for the average human is better. Like there's less pain and suffering, less poverty. And a lot of that comes from technology helping us to like make things easier and better, like getting clean water to where people need to drink it, basic stuff like that, all the way to like making things fun, where we have like infinite amount of information and this little thing in our hands all the time now. Just in our lifetimes, right? It's like huge change. So imagine what we can do for people and how much better we can make life for everyone in a really short amount of time, knowing all the tools and how fast this is going. Like in one generation, we could make it so that the kids are like, gosh, grandpa, how did you survive? You were burning stuff to make energy, like sending particulate into the atmosphere because you didn't realize space was infinitely full with energy yet. wow, you're old, grandpa. Like, we're in the old school right now. We're in the dawn ages. We still haven't figured out that, oh, whoops, there's an infinite amount of energy inside me right now. Like, maybe I don't need to dig into the ground and like burn stuff and put stuff into the air to make my piston turn my wheel and all this. Yeah. And that's why I'm so excited to work with Resonance Science Foundation and Nassim Haramein and all the gang, because it's trying to figure out the very front edge of the frontier of how all this stuff works and making the technology improve at the most rapid pace possible.
Yeah.
So leapfrogging away from just trying to make the combustion engine more efficient and being like, no, let's make space into the combustion engine and pull some of the energy right out of space, because space is everywhere. In between galaxies, under the ocean, in the middle of asteroids, there's space no matter what. So that's where we're headed, everyone. That's what we're trying to do here, is like ultimately what William's talking about is like, oh, let's work in collaboration with the way the universe already works, instead of like blowing up nature to try to force it to do what we want. That's like, we're learning fairly quickly, sort of. Yeah, could be faster.
Yeah, well, you're right. And it's definitely time. And we are confident that the scientific premise presented in this theory and by others around the world, because this is really beginning to get traction, and many scientists and researchers are coming to the same understanding that this is a vibrant, resonating universe and reality and nature, and that there are ways in which that is occurring across all scales that we can just come into alignment and mimic, to then go into the restoration and harmonizing process. And obviously that is the imperative of the day and every day that we're here. Why don't we go into some Q&A? And again, welcome everybody. I was just, once we came on, there's just people from all around the world, as always. And with lots of great questions coming in. I wanted to also remind you guys here on Zoom, when you're posting in the chat, there's at the bottom is a selection to change your setting to panelists and attendees. I see some of you just are still only posting to panelists. I think that's the default setting. So change your chat setting at the bottom of the chat window to panelists and attendees, so that when you post something, everybody can see it. So, and some of you have put questions into the Q&A. I'm sure most everybody here is familiar with it, but if you're not and you want to post a question, there's a Q&A button at the bottom of your Zoom window, and you can open that up and pop a question in there. And there's also a voting function to upvote questions to make them popular. And there's only a few at the moment, I'm sure, and we can just go to whatever ones we feel like addressing at any moment. And feel free to add more, you guys. I see, Jamie, that this first question has been tagged by you, if you want to start the conversation on that one. And what I will also do is invite you who have asked a question to come on screen with us, and I'll bring you up as a panelist. And if you want to participate, you can unmute your camera and unmute your audio. And if you would prefer not to, you can just leave those off, and that's fine. It's not an obligation to come on screen with us. So yeah, Jamie, why don't you take it away with the first one?
Okay. IM says, since the number of PSU in a proton, and I should say PSU stands for Planck spherical unit, which is a tiny, tiny, tiny little oscillator of space-time, the smallest unit that we can measure. And that's a long story why that's true, but there's 10 to the 60 of them in a proton. That's a 1 with 60 zeros. And so he's saying, since there's 10 to the 60 of these little Planck spherical units in a proton or so, and the number, whoops, and it moved, the number of protons in the universe is 10 to the 80, does this constitute an inconsistency in scaling? like as above, so below? Or does this not correspond to this simple, consistent building block progression of small to large as we scale up? And I think the thing that makes this hard to visualize is the difference between 10 to the 60 and 10 to the 80 is huge. It's ridiculous, right? Because we're talking exponents, right? So every time you add a single number, it's times 10, times 10, times 10. So even just doing that 20 times from 1 to 20 would be like a ridiculous quantity. But when you're going 10 to the C to 10 to the 80, it's hard to even conceive. What if it was 10 to the 81 protons in the universe? Then there'd be 10 times more protons in the universe. That'd be 10 universes bigger, right? So that's why it's, when I was saying before, visualizing infinity, forget about it, right? Just even visualizing 10 to the 80 versus 10 to the 60, you need graphics really to like do one of those power of 10 scaling zooms, like first came out in the 70s of the person lying on the grass in Chicago or whatever, it zooms out. Now you need to do that from the sub-Planck to the Planck is like the equivalent of the Planck to the universe. Then you're like, oh, we've arrived at the Planck, the smallest possible thing we can measure. And then you have to keep doing that super far until you get to the universe. And you're like, okay, inside there, there's how many protons? So yeah, no wonder it's confusing. And you're like, wait, there's only 10 to the 60 Plancks in a proton, but then there's only 10 to the 80 protons in the universe. Gosh, that doesn't make sense. It doesn't make sense because it's really hard to properly visualize scale relationships when you're dealing with fractals that are that big. Like the Mandelbrot set, you just like zoom in, you set your computer to start zooming in. You'd be like, okay, I'll come back in a trillion years and see how that looks. You know, it's like, that's how infinite it goes, right? So no wonder it's hard to visualize.
This is based on the fact that earlier on, many months ago, I asked a question of, would the universe really be a modeling of the Plancks or of the protons, or what would it would be like? A universal proton would be the map, if you will, of the universe. And then Adam at that time said, yeah, it would be more of a proton than a PSU. And I said, okay. So in just this analogy, we're looking at the universe being the universal proton, and it's got 10 to the 80 in it. And I thought, okay, scaling down, it just seemed to me, and apparently this is off. It seemed to me that one proton could be scaled down into the same number of PSUs. And to me, that would be a consistent, nice, easy, consistent scaling down. That would be just so, easily to visualize for everybody and to teach the kids and the whole thing. But that's a big number difference, like you're saying. So this is another thing I was thinking, this was just earlier today. I've been at this for months trying to get resolution on this. And because I know you guys are busy. So I'm glad, thank you for letting me ask this now. Is there something perhaps with the PSUs, not to change everything Nassim's done, but is there like, the protons have the neutrons, which are like energized protons, right? In an atom. What if the PSUs, if they got something similar in there that would raise the number to that being 10 to the 80th? Is that going on? Analogous. Yeah, go ahead.
There's a really important consideration here in that you have to consider the mass energy equivalence. If the number of PSUs in the proton were the same as the number of protons in the universe, it would actually have a factor of 20 greater energy density than the universe. You would actually be out in disequilibrium. So the thing to consider is that so each one of those PSUs have an energy of the Planck energy. So that's about 10 to the 9 joules. Because of mass energy equivalence, we oftentimes just describe it in terms of mass. So that's about 10 to the 5th grams. So if you had 10 to the 80 PSUs at 10 to the 5th grams, it would be, it would have orders of magnitude more energy density, holographic energy density than the universe. Right now, at 10 to the 60 PSUs, the energy density of the proton exactly equals, in terms of its holographic mass, exactly equals the energy density of the universe.
Oh, perfect, perfect.
Uh-huh.
Thank you, William.
Uh-huh.
That's it. That's beautiful. That's so simple.
That's the way you can describe it, is that you're talking the
That's-
density, energy density of the proton is a holographic representation of the universe. It already is. But if you just start to being like, I just want the numbers to match, it's not simple. There's the equivalence that William's talking about, and things can also change in a non-linear progression, right, where it ramps, right? So I think everything does that. I think everything's curved. Everything is not constant. It's all changing. Sometimes it's changing very, very slowly, like speed of light might change, but it changes super slowly over time, and we just haven't been able to measure that yet. So, but the fundamental aspect of the universal mass ratio is like the relationship between what's on the inside and what's on the outside. That's the key. So like these spheres, the nested boundary conditions.
Yeah.
And another really important thing is that, so if you have that energy density of the proton, which its holographic mass energy density is 10 to the 55 grams.
Right.
That is the mass of the universe, the observable universe. If you were to inflate that proton to the size of the universe, it would produce exactly 10 to the 80 protons out of those Planck spherical units. So it actually is equivalent. It's just that trying to think of the PSU as exactly analogous to the proton in the universe. It's not, because for one thing, in the proton, there's no space in between those PSUs. They're actually overlapping because they're waveforms, so they're overlapping and actually forming basically a flower of life template.
Yeah.
So it's not like an exact comparison because in that sense. But if you were to suddenly expand a single proton to the size of the universe, you would have 10 to the 80 protons in it.
Yeah. That's great. I mean, the numbers still match, but it's not numbers of units. It's mass density.
Mass energy density.
It's the same number as above, so below. So
yeah.
I wanted to satisfy that. It's beautiful. By the way, I'm still in Egypt. I was in Abidan. I did see the flower of life in the Osirian. I went out in the backyard there behind the temple of Seti I, and it was closed, and they wouldn't let me go down in it. I could see it from a distance, but the police are all over it. It is shut down, and I was so disappointed. I wanted to be there. I wanted to get close ups. I wanted.
Yeah, you have to get special permission for that site.
Yeah, he said, yeah, you got to go to Cairo, get permission, come back. I said, oh, yeah, okay.
It's a
but
process.
Just wanted to let you know that.
That's cool. Great.
Yeah.
Well, thanks for beaming in from Egypt.
Thank you so much. You guys are.
Oh, and one more thing I wanted to add about this is, remember that like Nassim was thinking that possibly that there was a universe and a proton escaped the event horizon of that universe and was like, oh, this space is really different density than the other density. So I got to equalize this density. So I'm going to have to get really big, really fast to equalize that density. And that's the Big Bang. Like we were a proton popping out of a universe, and that's what we think is the Big Bang. And, just yesterday, I saw a friend whose kid was like, wait, what happened before the Big Bang? What's on the outside of the universe expanding? And I'm like, exactly.
Right.
Smart kid.
If that's the case, and it had to follow the same exact blueprint, would that be all the other universes have to have the same physics and everything? because we got one that escaped and it did the same thing? Or
I
mean,
like to say, you could have the Pope and Stephen Hawking in this Zoom right now and ask them that question, and I'd give them equal weight in their answer. Right? Like the religious people and the physicists don't know what happened before the Big Bang. That's why it's so fun to be alive right now, because we have no idea how we got here.
Always something will be unknown. Yes, always. The mystery goes forever. Thank you. Thank you again.
Okay, you're welcome. Thanks for being here.
Save the world, guys.
In together.
Yeah, no pressure, no pressure. We all are working together to try to figure that one out.
Willem, you want to jump in on a next question?
Yeah, so there's a really good one here. If the galaxy is like the brain, the heart would be where/what? The sun? This was asked by Iwa. So just one point of clarification. The neuronal architecture that was observed was at the supergalactic scale. This is actually, we're talking about hundreds of millions of galaxies that come together and form this infractuous dendritic pattern that recapitulates the organizational structure of the brain. Not exactly just a single galaxy there on where you're seeing this similarity. And it's kind of just that point is kind of an interesting one in that you have what appears to be scale invariant complexity, where if you go up 27 orders of magnitude, you have the same level of complexity. So let's say you're at the mesoscale of the biological organism, the animal brain, animal central nervous system. You scale up 27 orders of magnitude. And, remember what Jamie was saying, those are powers of 10. So that's doing times 10, 27 times. You get the same level of complexity at that cosmic web level. And we strongly believe, as me and Marshall were discussing, that if you go down 27 orders of magnitude to the Planck scale, you probably have a recapitulation of that same organizational structure. But what's interesting is that it does seem to have these very set intervals where you'll have a high degree of complexity, and then it kind of transitions through a domain of very low levels of complexity. So an example of this would be the surface of the Earth, the biosphere, which has a high degree of complexity. But as soon as you start moving up to, say, the scale of the solar system, the level of complexity just drops off significantly. And in fact, the solar system is kind of such a simplistic system that you could run it in reverse, backwards in time, and nobody would notice, because it would look pretty much the same for at least 4 billion years until you start to notice that, wait, I think it's going the other way in time. And, something like that, that is kind of time invariant in its level of complexity, is not a very complex system. But then, you go up another interval in the scale to multiple stars, and there you start getting some complexity to reemerge. These stars are connected by magnetic filaments, plasma filaments. So actually, if you were to see a local cluster and you could see some of their space-time connections and magnetic connections, it would actually look pretty very similar to like a neuronal network. And then another interval where it kind of gets simple, the galaxy, the galactic disk, where it's just kind of the stars are going round and around. So that's kind of an interesting consideration in all this. Now, in terms of the heart, so we're comparing all these to a neuronal structure, but that's kind of just because that's one of the simplest comparisons to do, and the one that people would be most readily familiar with. Now, the heart, if you actually consider the entire cardiovascular system, the heart isn't just the central pump there. It extends and touches every cell in the body. And that is a dendritic neuronal architecture. The capillaries and all of that. And it's conducting electrical signals, acoustic signals. So it's involved just as much as the central nervous system in communicativity. So you could actually just as easily say that the cosmic web is recapitulating the architecture of the heart. Especially if you look at the interface of the heart in the brain, or the brain's heart, but let's say the heart in the brain. So you don't have a single neuron that is more than 100 microns away from a capillary, a blood vessel. And in fact, if they are very far away, they're accompanied by microglia. And so you have about, I believe it's 50 billion neurons, and you have a equal number of what are called glial cells. And glia, that's actually Greek for glue. So, in total, it's about 100 billion cells in the brain, which is the same as the number of galaxies larger than the Milky Way in the universe. But what you'll have is the glia are always right there next to a neuron, and they send out what are called podia, or little feet. That's Greek for feet, podia. And there are these extensions that extend into the synaptic cleft. So that's the communication space between a dendrite and an axon, two neurons. And then they have another filament that extends out, another podia, foot, and it wraps around blood vessels. So you actually have these regulatory cells in the brain, and the regulatory cells are latched on to the heart. And they send these extensions directly into the synaptic cleft, and they're regulating the communication there. So the the brain's extension, the heart's extension into the brain, or more that the brain is an extension of the heart. There is a lot of regulation and control that the heart has on the activity of the brain. So I would almost equally consider the cosmic web. You could call it the heart mind, in its architectural organization.
Yeah, that's really cool. Again, it's one unified system, and to see how that's actually functioning that way in the body. It's always been my understanding, and you're helping to clarify how that's so, is that the brain, central nervous system, the heart, and the solar plexus are all really a fractal antenna system for transmission and reception within the field of the unified space memory network, and the levels of organization and harmonic structures that meet in our systems at this level. So yeah, it's all the same kind of a system.
And this is very much where you kind of tune the dial on your reception.
Tune the dial. Yeah.
Yeah. Okay. I just saw it's 86 billion neurons. So
86
yeah,
billion.
I was want to say 50 or 100 billion, but it's actually right in the middle there, 86 billion neurons.
I actually
Right.
posted that Nassim quote about how if the brain is the radio's receiver, then the heart is the dial that tunes.
Mhm.
So, I mean, some of this comes to semantics, right? If you want to try to talk about something that's infinitely complex, infinitely embedded, like just saying the heart, most people are like, oh yeah, that's that muscle that goes like this and it pumps all your blood. And it's like, okay, but it's so much more complicated than that, as William just told us about. And so the same thing happens with the nervous system and the kind of antenna that we have, and then the interaction of the quantum vacuum with the biological resolution of our bodies. So complex, right? So just to say, oh, okay, if the galaxy is like this to the universe, then what's the heart to the? It's like I'm just trying to frame something super general, and you have to remember the infinite like connection neural network that is embedded through everything, the quantum wormholes. 10 to the 60 PSUs in the proton with 10 to the 40 quantum wormholes coming off the event horizon of that proton, spinning at the speed of light. You're made of quintillions of those or octillions of them, something like that, right? We're made of such complexity. And so just to generalize is like, okay, we have this antenna, we're vibrating, we're picking up information, and then we have this thing called emotions that we somehow attach to our heart. Like when you feel sad, you feel it in your heart. This is all very generalized, kind of like abstract way of talking about something that's highly complex, but then you can kind of talk about it that way, right? Okay, fine. Well, I feel like this, so I'm going to tune my consciousness and try to resonate with the fundamental frequency of the field. And then people that can do that really well, you can tell because they're really centered and happy and they meditate and they don't need to eat as much and they have a lot of energy. And you're like, how are you doing that? Oh, well, I've been trying to tune in for a long time. So like, what do you mean tune in? And it's, oh, I'm pointing my attention into the stillness in the center so I can get the spin to happen in the right ratio to all the other stuff that's going on. It's not simple, right? We're all just kind of navigating, being like, okay, what's happening now? Oh, I got to swim like this now. Oh, I got to constantly adjust, constantly, like birds flying, they can turn their wings and like, oh, a gust of wind happens, they instantly change the way that they're, you have to do that physically, you have to do that in your emotional state, you have to do that in your vibratory physics state, you're doing it at a quantum scale, epigenetic style, telling your cells information that makes them resonate and do things like heal yourself, which we all can do. All this unified physics actually applies to psychology and emotional, time, biology, chemistry. It's like it affects everything. It affects society, technology, interactions. So it's a profound question when you just to say, oh, what's the relationship of the heart to all this stuff? Is it like the galaxy to the universe? You can generalize, but it's always more complex than we know. Again, why it's so interesting to dig into this stuff.
Great. Cool. All right. Well, let's continue on with some questions. So there are two from Tommaso here, and I'll bring Tommaso on the screen. And mine just switched here off screen. And I think even what we were just talking about will speak to this first question. If everything is interconnected and information travels around different universes and gradients in the fractal structure of the space memory network, then we can say that also conscious beings in this and in the other infinite number of universes are virtually interconnected on a physical level. If that is true, is it fair to say that it can be theoretically possible to have conscious communication between us humans and conscious beings in other space memory coordinates? And Tommaso, I'm going to bring you on the screen if you'd like to come on and join us. Yeah, so that's a really good question that fits into this understanding of there being a unified space memory network and a universal exchange and communication. Hi, Tommaso.
Hi, how
How
are you?
Good. How are you? Where are you from?
I'm fine, thank you. I'm from Italy, from
Uh,
Padua, northeast of Italy, half an hour from Venice by car.
oh, yeah. Okay, good. Good. I've been up to that area. Been to Damanhur a couple of times. You know Damanhur, yeah?
I'm sorry,
Do you know Damanhur?
no, I don't know.
Oh, it's not too far away from you. It's a eco-spiritual community that built a temple inside of the mountain. Uh,
Oh,
you would
wow,
probably enjoy going there. It's quite an amazing place, not too far from
okay.
you. So
I will look into it. I
maybe
didn't know about it.
maybe Jamie, if you would pop a link into Damanhur in the chat, so people know how to spell that. That would be great.
Nice,
But
thank
welcome.
you.
And so yeah, it's an interesting question. And if you consider there being a unified um, informational network that then, as we've been describing, as complexity increases across scale, then there's more of an informational coherence that also increases in complexity to then ultimately exhibit attributes of what we call consciousness, intelligence, awareness, self-reflectivity, um, and other attributes in this one unified network. That when we talk about conscious beings, we often refer to that as our frame of reference is as a human being, and so we tend to project the attributes we identify with onto the rest of the universe to see, is there something that might correlate and might match, when in fact, this is just one version that is relative to our experience. And so when we talk about conscious beings, we could ultimately correlate that to any and every scale. I know the physicist David Bohm, who worked a lot with plasma and electron plasma flow, that would exhibit these behaviors that showed some kind of a awareness and intelligence relative to other things in their environment. So even at that scale, he really kind of posited that there was these same attributes were present. And so, but when I think your question is in relationship to other beings that may be of a similar character to we are, that have a similar kind of an intelligence and awareness, and maybe bodies in a similar manner as we do, or whatever it might be. Can we, through this network, be in communication with them? And I feel confident that probably all of us here would say, yes, that is true, that we can. We were just talking about how the heart, the heart can serve as like a tuner, like tuning a radio. And it would be through this kind of tuning or attunement with another being, another entity, another energetic source, that frequency and the dynamics and characteristics of it. For example, we might be able to connect with an intelligence that is not in a human body form. And when we can allow ourselves to tune to that construct in a way by letting go of our frame of reference just enough to be able to come into an attunement, to tune and match whatever that construct may be. It's something in pure consciousness, or however it might be experienced, or even seen visually internally, or heard through a mechanism of an auditory transmission or something like that, that we are tuning into that connection, and that would make that possible. And the model of the Unified Space Memory Network indicates that would be certainly very most likely and very feasible to do. And I know that there are increasing numbers of people who work in the healing arts or do remote viewing or other kinds of long distance direct connection that are able to communicate with other, let's say just people on the planet, through this unified field, to have an instant and accurate communication and perception with that other being. And that being the case, which I think is at least, well, I think is both anecdotally researched as well as clinically researched to a degree, to be proven to be true, that would of course then extend, because the whole thing is unified across all scales. So it would extend to that being true with other beings in other universes and other realms.
You need a really big answering machine, like really, really big, because you cannot answer everything, you know, like it's like
you wouldn't want
like
to try.
like an app to like, okay, I'm coming, this information comes from this universe and I need to answer to the other one. So
That's why it's important to have, you know, the appropriate tuning and filters to filter out all the other stuff. If you start tuning into all of it at once, it will be complete overload. That is for sure. So, and your other question has to do with time. Is time a dimension, or is it a parameter we set in a system to understand better the structure of reality? Would it be fair to? Mhm.
if you want, I can expand, because
Yeah.
I'm not a like I haven't studied like physics like deeply enough, but like the example of Einstein relativity, where the I understand that like if two people, one staying in the planet, another one on a spaceship that travels with the speed of light, the person that travels with age differently, so its cells will change at a different speed. But so that is a changing of the structure of the material structure of the space. So actually time doesn't exist. It's just that we as conscious being, or we as a point of information that are being received, acknowledge that there is a change of matter. But so my point is that time doesn't exist. That's why William and Nassim have used the word memory. So I would like for you to expand more about the concept that time is more an illusion. If you can have like a let's say input around that concept.
Sure, William, why don't you speak to that a little bit?
Yeah. Great question. So right now, in this now moment, there is no past or future. Every space-time coordinate is a now moment. So why is it that in this now moment, you believe there was a past, hence that time has elapsed? The reason for that is that the information from other space-time coordinates that are simultaneously coexistent is being recorded into the space structure of your current space-time coordinate. So what we call the past is actually a instantaneous information accessing of the space Planck quantum structure. And so the interactivity, the intercommunication of all the countless space-time coordinates, the information being fed through are shaping the characteristics of this current now moment, this current space-time coordinate. But this, you could think of it as this space-time coordinate exists distinct from all other space-time coordinates. So in this sense, it's very actually important to consider it as a fourth dimension. And we call that fourth dimension time. But what that means is all the different parallel coexisting space-time frames, which are essentially parallel universes. It's a multiverse structure. And so that's where we replace the term space-time with space memory, because fundamentally there is no time. Everything is occurring instantaneously, eternally, in this block dimension that is the fourth dimension that we label as time. Now, it's really important to consider time as a dimension, because we do say that fundamentally everything is that there is no time. That is, it's eternal and it's an instantaneous now moment. But the universe kind of has this interesting thing where because of relativity, it simultaneously does everything at once and simultaneously stretches it out and presents the illusion of a linear sequence of events, even though everything's happening all at once instantaneously. And that led Einstein to actually say, time is an illusion, albeit a very persistent illusion. So it's like you run into trouble when you say there is no such thing as time, because your next sentence in describing it, you use the mental construct of time. So it does have a certain validity in that sense, and that has to do with the relativity of simultaneity. So and that's also where it's really important to consider time as a dimension. So, for instance, a photon being emitted from a star, let's say 600 light years away, most people will say that star is 600 light years away. It takes that photon 600 light years to travel from that star to hit my eye and travel to the retina and send a signal to my brain that I just saw a star. Now, because of relativity, since the universe is doing those two things simultaneously, that is true. It did, from your perspective, from your relative frame of reference, take 600 years for this photon to travel through space. But actually, the more true, the other simultaneously true, and it's a little bit closer to the reality of things, is from the frame of reference of the photon. For the photon, it took exactly 0 time and it traveled 0 distance. From the photon's perspective, your retina is resting on the surface of the star, and it just instantaneously went from the surface of the star to your retina to your brain. And so, I mean, talk about everything being one at the speed of light. It's literally everything is one. There's no spatial distance between anything, and there's no temporal distance between everything. And we don't experience that, but it doesn't mean it isn't happening, or actually a valid structure of the universe on how it's organized. It's a singularity, a black hole. And that's actually why you have this speed of light. So, understanding that, if you understand time as a dimension, it makes that, I think, a lot easier, because when you start talking about like the past and the future, if you consider a spatial dimension, let's say you're in the park and there's a path and it starts at point A and ends at point B. when you're walking along that path, when you go from point A to point B, you don't suddenly think when you're at point B that everything behind you is gone. That was the past and it's now gone. You know, no, this is a spatial dimension. Point A is still there. I'm just at point B. When you consider time as a dimension, it's the same thing. That time A, when you're at time B, you think, oh, that's the past, it's gone. It's not gone. It's in its space-time coordinate at the temporal location of timestamp A. Yeah.
What about the future?
The future is the same. Yeah. So let's maybe go starts at point A, ends at point C, and the middle is point B. So if you're at point B, you think that that's all there is, that there is no location C or location A. If this spatial distance was analogous to the time dimension. But what Einstein said and proved is that time is just like a spatial dimension. So when you're at point B, time coordinate A is there simultaneously, and point C, the future, is there simultaneously. Now, in this analogy, though, we would have this restriction where we can't send any signals to C and receive them until we're physically at the location of C. And same with A. That is the restriction imposed by the speed of light. So the speed of light restriction for signal transmission. And so if we're at point B, we can't communicate with anybody at point C or point A because of the speed of light restriction. And so it creates the illusion that all there is point B, because we can't receive any information from A or C, unless you use some of the other tricks that the universe does that Einstein really didn't like, which was quantum mechanics. In that case, you can start to actually receive signals from point A, point C and point A when you're at point B. And it does it in such a way that you don't violate causality or relativity. But that is actually one of the crux, one of the main points of our paper, me and Nassim's, the Unified Space Memory Network, is that so the reason why we have all this information about the past, the path from A to B, is that the information is being accessed at that point. One of the important things is that the information is also being accessed from point C, what we call the future, which is simultaneously existing. It exists right now. Now, the information being accessed from the future is actually what produces the characteristic of evolution. Instead of going into it into too much detail, basically, those future locations in the dimension of time that have the highest level of order and coherence, they have the highest amount of entanglement, quantum entanglement, with your current space-time location, and they actually act as a veritable force, pulling you in that particular direction. And so we actually use this transtemporal communication of time through the space memory network that's occurring faster than the speed of light, quasi-instantaneously, to explain the mechanism of evolution. So the question that you're asking is central and pivotal to understanding physics, and particularly unified physics. And it just, I still see it time and time again that a lot of people, and especially even scientists and astrophysicists, don't seem to understand that concept, that time is a dimension. Because I was watching like PBS Spacetime not too long ago. And the astrophysicist on it said that traveling at the speed of light means that you can't have interstellar travel because the distances are too long and it takes too large and it takes too long. And that's still given as a reason why you can't have other intelligent civilizations like, say, visiting Earth, is because the distances are too large. And then whenever they're talking about gravitational drives, warp drives, they can go faster than the speed of light. They'll say, well, all of you who were hoping to be able to travel the galaxy, we just found that there's this problem with warp drives because they need a whole bunch of negative energy and stuff. They're still kind of figuring that out. But so the point, though, is that you don't need a warp drive to travel interstellar distances. You don't need to go faster than the speed of light because time is a dimension, and so it can contract. When you're traveling close to the speed of light, distance contracts, time dilates. So less time goes by when you're traveling at speed of light relative to an inertial frame. So you could travel to any star system arbitrarily fast without going over the speed limit. If you designed a propulsion system, a gravitational drive, that could supply sufficient space-time curvature, you could go 99.99999% the speed of light, and you could jump over to Alpha Centauri, our nearest stellar neighbor, in a matter of minutes. You could actually go arbitrarily fast. So it's an important point that I'm really getting passionate about getting this across.
Thank you so much, William. That was really I really understand, because you crack one little things that I didn't understand. Just one question, that's it. What about materials to build this spaceship? Materials.
Materials to build a spaceship that could go 99.999% the speed of light. Yeah, well, so that is, though, a interesting consideration. So and it's something that so
maybe rock, or maybe like quartz, maybe something like similar as a rock, or like as a crystal.
Well, the solution to that is just that you actually, though, do need a warp drive. You don't need to go faster than the speed of light, but you do need a warp drive, just because you're not going to get to 99.999% the speed of light using thrust, using a reaction propulsion mechanism with Newton's law, where you create thrust out the back and it pushes you forward.
You need a space-time vacuum cleaner.
Yeah.
Because you get sucked towards a black hole to move really quickly.
Yeah,
exactly.
What material do you choose to be attracted by a black hole?
Well, if that were the case, so if you were generating space-time curvature, really you could use just about any material, because there would actually be no G forces, no inertial forces on the craft you were using. I mean, if it was a handheld gravitational device, you could be in a spacesuit and it would carry you along. And if it only took 2 minutes, you could be in a spacesuit and go from here to Alpha Centauri. But
if only you were on 60 Minutes this Sunday, William. Because I mean, 60 Minutes, the most mainstream news program in the history of the United States, is like, yeah, I'm a Navy pilot and I saw this thing that was moving around. Like, the stuff that it was made of, it didn't matter how fast it went and how quickly it turned at 90-degree angles, just like what William was just saying, right? Like, this phenomenon is there and we're observing it, and now it's on mainstream television. So like, it's coming. All that we're talking about there's folks out there that know this because we're seeing it, and I call them folks because they're people.
I
Let's
would
leave it at
purpose.
that. Let's leave it at that for now, because we have a bunch more questions to get to before we wrap up.
Okay.
But
Thank you so much.
thank you, Tommaso.
Bye bye.
See you again.
See you.
Okay, be well. That was great. Wow, William, that's it's
Yeah, thanks,
really
William.
takes a lot to wrap our minds around, but you always make it accessible for us. We appreciate that so much. We'll bring on Lynn Leslie here, longtime associate and friend of the Resonance Science Foundation. And Lynn is asking about the notion of using cymatics for healing. Since we are 70% water, including in our DNA and brain cells, sound waves could transform us at a cellular level. We're already using ultrasound in diagnostic medicine. Could cymatics restore healthy, natural patterns? All right, Lynn, I'm going to bring you on. Okay.
Basically, I think of us as being cymatics. The whole universe is cymatics because everything is vibration. Hey, Lynn,
Make sure
you're on mute.
unmute your audio for us. You still have to unmute your audio. We're not hearing you. There we go.
Something that you were all talking about earlier triggered this for me, because there's a lot of cymatic videos on YouTube where you see the vibration making water run down zigzag, or you see the sand or the cornstarch or something like that with all the sound waves moving through it. So it seems to me that this would be like a natural next research in biomedical engineering or just biology to see how these sound waves can affect our tissue and our cells. So I'm just curious to see what you think.
Mhm. Well, I think what Jamie was just saying, how everything is subject to the same vibrational phenomena, and my sense of the physical universe is that there's an interplay between the electromagnetic unified field that is at the foundation of all of the interactions that are occurring across all scales, that then come into different densities of across the density gradient into different degrees of compression, and that compressed physical manifestation I correlate to the acoustical nature of the universe. And so and it's really all one and the same thing. Obviously, we have to use these words to distinguish between different characteristics. And yet, the electromagnetic and acoustical are interchangeable, and they're all based on the same fundamental premise of vibration and resonance. And for resonance to occur, there has to be coherence. And when we talk about cymatics, for those who are not familiar with cymatics, it's a technique for being able to visibly represent or present, actually visibly make visible in a medium such as water, like a little cup of water, maybe an inch in diameter, with an audio speaker underneath it, will vibrate. The sound coming through that speaker will vibrate the water, and the vibration of the water will then you can have a ring of lights that will reflect off the surface of the water, and you can see the pattern of the vibration of the water, and it becomes very coherent, very symmetrical, geometric, very stable in many cases, and shows us that that the coherence and the resonance actually has geometric symmetry and relationship to it. even when it's something as simple as sound moving through a liquid. And so then we correlate that to all the other aspects of how form and resonance and coherence are occurring, to then consider, well, the cymatic nature is potentially present throughout the entire system.
Nassim has spoken, and William has too, about how water is the medium that transmits information from cell to cell, that it actually kind of gets deformed, say, like as it leaves our DNA and passes through the membranes and gets out into the other cells in our body to carry that information from the DNA and RNA. So cymatics could presumably actually work on changing the shape of the water as it's moving from cell to cell in a way to restore the healthy patterns and to break up some of the unhealthy patterns. And someone posted on chat that there's a group that's already working on this. So that'd be interesting for me to research.
Yes, check that out. And you know, the idea that there can be identified coherent resonant geometric patterns associated with cellular activity, structure, organs, you know, at the next level up into the organs, into the whole biological system, and et cetera, et cetera. Certainly that makes good sense. And then therefore the application of external sources of sound that can engender that coherence, once maybe there's a certain frequency and pattern correlation identified, then the restoration of that pattern when it's gone out of symmetry, out of coherence, certainly is possible. And I think actually there are technologies already doing it. I think a great example is the work of Eileen McCusick that I've mentioned in prior sessions here with the biofield tuning. If you go to biofieldtuning.com, you see her work using tuning forks, which are very coherent, resonating, auditory or acoustical instruments that she just uses within the field, the biofield around the body, to identify where you know, the practitioners of this biofield tuning can take a tuning fork, put it in the field, and they can both hear and feel where there are different changes within the biofield. And when something is in some ways maybe damping or diminishing the resonance of that tuning fork, they can bring that coherent sound vibration into that place and help to restore it back into a coherent state. And when that coherent state is achieved, maybe there's physical or emotional or mental symptoms that can be released at that point. And they have great results with that kind of thing. So
this is alternative medicine. I don't know if this is happening in mainstream.
Not yet.
Medicine,
it will become mainstream as the science becomes mainstream, that's for sure.
Yeah.
But yeah, and in mainstream, I think there are some technologies that are certainly heading in that direction, I believe. And I think that's accelerating at this time as well.
It's mainstream if you consider magnetic resonance imaging, MRI machines, which are so incredibly useful and diagnose so many things. That's a very, do you agree, William, that the MRI is like, for medicine, it's been a game changer? I mean, I'm not a doctor, obviously, but how many times have you heard about somebody like their life being saved because, we weren't sure, so I got an MRI and now I know, and so I was able to like treat myself and now I'm okay. Like, so we are already on to that, but there's, you know, very specific use cases that in some cases have been squashed by the medical community. Because it's a very complicated system we have of information flow and who gets to say what, where, and when, and what gets adopted and what doesn't.
Well, it is a pharmaceutical.
But
So
what's that? Lynn?
isn't pharmaceutical. I mean, if we were to find a way to use tuning forks and other sonic targeted beams to produce healing effects.
Yeah, it's complicated because a tuning fork is not something you can easily patent the molecule for and get a revenue stream that lasts for decades and stuff like that. So yeah, it's that's why it's important for us as a community globally, people that are interested in really figuring out what's actually going on and pushing the envelope forward and not just accepting what we've done in the past, is that we all need to like get the word out on, oh, look, there's something that's effective, that's real, that's true, that's correct, the new physics, new science, proving that this thing is real. So don't let those guys squash the thing because they can't make money. Let's like help people help themselves worldwide on all levels, not just medicine, on all the things, on technology, systems, politically, all of it. So, and thankfully we have the mechanism to do that, like what we're doing right now, where I can just go blah, 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 and my voice goes into this box and it goes across space, through space and time. And then you're sitting wherever you are on the surface of this sphere being like, oh, cool. I'm going to share this, you know. So thank you guys out there for helping to share the resonant information of all the people that are making incredibly resonant information.
The research into using sonic waves to clarify the pineal gland also are available on YouTube. Those are some that you can listen to, and you get those binaural beats. And but again, none of it is mainstream, and that's part of the important work of this group.
There is research being done. Not too long ago, I was talking with a research group at U of A in the neuroscience department that are using ultrasound as a way for, it's akin to magnetic deep brain stimulation, but in this case, they're using ultrasound. And they use ultrasound just because the size of the wave frequencies in the ultrasound wavelength range are really small. So you can pinpoint like a specific region of the brain and get it to resonate and introduce that kind of acoustic modulation. And, you know, they can actually go down into the limbic system and say you have somebody who's dealing with depression. Instead of Big Pharma giving them a pill, you could hit them with the sound, hit them with the sound. You could introduce this harmonic wave frequency into the limbic system and alleviate those symptoms. So it actually, it's not quite in the mainstream yet, just because it's really new in terms of medicine and biology on understanding the role that light plays. So you know, light therapies are starting to get into the mainstream, you know, especially like red light therapies, blue light therapies for bioregeneration, all these kind of things. The role that sound plays, you know, it's just now starting to kind of get into the mainstream areas of research. So it's just not quite understood yet. But you know, even in terms of the cell, the plasma membrane is a fluid membrane. It's a fluid, and it has cymatic patterns on it, and actually the acoustic patterns occurring in the cellular membrane do transmit signals. You know, that's not like unknown thing. There's you know, scientific papers on that mechanism. One researcher, Dr. Ben Mokhta, has done just some of the most fascinating work with the plasma membrane. His research team showed that whenever you have a electrical signal traveling along the neuron, it's actually coupled to a mechanical wave, an acoustic oscillation. So the plasma membrane is piezoelectric. So the electrical signal is inducing this acoustic
Wow.
oscillation. And that's one of the ways that if you introduce sound in this targeted way with ultrasound into the brain, you can modulate certain properties of it.
Mhm. At an electrical level.
It'll modulate the electrical activity via the
Yeah, yeah.
sound.
Yeah. There it is. It's
Yeah.
all one and the same thing.
All one and the same. Yeah,
That's
yeah,
great.
yeah.
Great. All
Plus
right.
all water in there.
Yeah,
And the
that's
water.
right. Yeah, a lot of water in there.
Yeah, yeah.
Well, thanks, Lynn,
Oh,
for being
thank you.
here.
Thank
Good
you.
to see
all.
you.
Good to see you.
All right. Take good care. I think we're going to leave it at that today because we like to try to keep these to an hour and a half, and we're a little bit beyond that. And I know there's a bunch more questions here. We could keep going on for a while, but does that feel okay to you guys to wrap it up at this point?
Yeah, resonance. Wrap it with the resonance.
Yes, wrap it with the resonance. That's right.
I mean, that's why Nassim called it Resonance Science Foundation, right? It's like it's so foundational that he was like, let's make a whole foundation based on resonance, because
That's
it
exactly
really
right.
comes down to that.
And that is the, as we were just talking about, the direction of medicine, the direction of agriculture, agricultural applications, the mitigation of, toxins of nuclear radiation, all the stuff that using resonance, understanding the relationships that will enhance and bring vitality to or diminish and ultimately neutralize things like radiation, all based on the same fundamental principle of a vibrating universe and the resonance and the constructive and deconstructive aspects of how that's all relating. It's all musical. And we're seeing that progression as we were just talking about, and I think we all can feel confidently say that the direction of medicine, as we're just talking about, is absolutely going to go in that direction, and we'll get away from what is currently in many ways making our bodies and our world less healthy because of the detrimental side effects of using the chemical-based approach. When we clean that out and restore the vibrational balance, it will very quickly restore not only our bodies, but the ecosystems of the world and all the elemental aspects. And it's exciting. It's easy to understand how that works. And we love exploring it with you all, in these settings, and appreciate all your questions. Sorry we didn't get to everybody today, as usual. So there's always more questions than we can get to. But we really appreciate your being here. Thanks, William and Jamie, for joining in today. We'll be back in June, and we'll see who's able to join us at that time. Probably get Adam in here and S back on, and we'll see who else. Probably
Marshall, thank you.
Green.
I put a link to your website in the chat of the Zoom.
Thanks,
if you guys like what Marshall is saying, you'll love his book and his website at cosmometry.com. I put it in the chat.
Great.
And then also check out William's course, Big Questions in the Resonance Academy, super deep. If you like what William was saying, you're going to love that course. I put that link in the chat as well. Thank you guys both for great ability to take a huge amount of information and condense it down into bite-sized chunks so that people can start to dig into this stuff. You guys are both super talented in that way. Appreciate you guys.
Thanks, Jamie. Appreciate it. Thanks for all you've done to carry this out into the world for a long time as well and make it accessible for people.
It's an honor to help amplify such incredible
Yeah.
people and information. So thank you all out there for supporting Resonance Science Foundation. You'll notice in the chat of both YouTube and Zoom, I put links in there to the free course. We have a free, very comprehensive 6 modules, soon to be 7 and 8 module course that encapsulates Nassim Haramein's lifetime of research and all the Foundation Academy faculty research as well. And then there's actually, you can be a contributing member of this foundation and support these researchers and help us to get the word out, because we kind of need to do it like super exponentially really quickly. So all the help is super appreciated.
That's for sure.
William, you got his final closing words for us?
Oh, well, thank you all for joining us. Thank you, Marshall and Jamie. So much enjoy these faculty Q&As, these discourses. Also, I think you forgot to mention, Jamie, that you have a course on the Resonance Academy, Ancient Civilizations. It's a must-do course. Comes highly recommended as well. So definitely check out everything that the Resonance Academy has to offer, because there is a lot of really mind-expanding content available there.
That's for sure. And some good ones in the works yet to come.
Thanks, William. Yeah.
All right, everybody, take good care out there in the world. Give each other lots of good support. Be in good heart-centered compassion for all that's happening in the world. And let's pour this love and understanding into our human family, that we can bring about a peaceful and resonating and coherent experience for all. And we'll see you next time. Take good care in the meantime. Aloha, everybody.